Okay, cool. So we're recording. This is March 23rd, and this is our using query call. And for anyone who's new or hasn't been on the call in a while, this is sort of our queries team's opportunity to connect with users of the software that we make free and open source, learn about some of the work that they're hoping to do, and see how query can support that, as well as show off any features that we're working on or planning to be working on. And since we've got some new folks today, I thought we might spend a minute or two and just hear about what you're working on and from a data perspective. And then we could talk a little bit about how query can support that before we go into maybe demoing some stuff of the latest work we've done. First, raise your hand. Well, if you're visual, if your camera is being shown to you, you can go ahead and raise your hand if you're a member of the query team so that Holger and others can sort of identify who we are. I'm Rico. Anybody else on the query team want to introduce themselves?
Sure. I'm Dustin. I'm a engineer on mostly the backend part of query.
My name is Brendan. I'm the caretaker for the project.
My name is Christos. I am a data research assistant.
My name is Rusty. I write data stories like Christos does.
And Chris dropped a little wave in the chat. He might not be able to add sound and video from where he's at right now, but he's an outreach engineer. Oh, there he goes, Chris. Go ahead.
I can say hello. I'm an outreach engineer. Just rather stay off video for the time being due to my present home situation.
All right.
Very understandable. Yeah, with that in mind, Holger, do you mind if we put you on the spot and just ask you what questions you maybe had for query and make sure that we answer those right out the gates?
Yeah, I'd like to. I'm Holger from Stuttgart in Germany, and we are an initiative doing some open data, open source stuff, intermodal routing, carpooling especially, and we're working with data sets from transit agencies here in the region, and there are plenty of GTFS feeds, not updated very regularly, and well, the open data stuff is starting here, but not working that very well. But well, and I read, I followed you on Twitter, and it seems very interesting what you're doing. I had not the time to dig into, but yeah, sounds very interesting, and I'd like to learn a bit about it and yeah, just listen a bit. I posted a couple of links to datasets, GTFS feeds. I'm not sure if such data sets distributed in various files handleable as well via query, or if it's only table-only data. So yeah, I'd like to learn a bit more. And yeah, thanks for having me.
Absolutely, yeah, and it sounded like based on the Twitter conversation that was happening, one of the things you were interested in is actually calculating differences or changes over time in GTFS feeds. Am I correct in that assumption?
Yes, in GTFS fields and other transport-related data, yeah.
Gotcha. Okay, and so for those who aren't familiar, GTFS feeds, and Holger, please correct me as I make any of these descriptions, but a GTFS feed is sort of a standardization way of delivering sort of transit times and station stops. A number of places around, like a number of different transit systems use it. If I'm not mistaken, Chris, you can correct me on this, but the Metro Transit Authority here in New York does use one, a GTFS feed. And what they usually consist of is 11 CSV files that are updated fairly frequently. And so each of those CSV files consists of sort of standardized things like stop times, speed information, transfer information, calendar dates, the actual calendar of services and stops, trips, routes, and agencies. Those are all of the fields involved in a classic GTFS feed. Each of those files changes with a different frequency. Some of them are, and they all use sort of like common identifiers for mapping different services. So you can sort of think about it as a CSV database representation, like it's something that would sort of very easily dump out of like a set of Postgres tables or sort of tabular database, relational database tables. And so a lot of the GTFS spec was established to do coordination across systems. So if I'm not mistaken, it's how Google does the majority of their transit time reporting. They're actually pulling, when you're looking at Google Maps and it says the subway's late, that's actually under the hood is a GTFS feed at the bottom of that stack. Casey, who worked yeah, thank you, Chris, please.
So, sorry, worth noting, GTFS Classic is basically a machine-readable data standardized version of a transit schedule, which means it's only accurate if everything's running on time. There's another standard called GTFS RT or GTFS real-time. So our city uses both of these for the subway, but not all city. It's probably a lower lift for any entity to do a GTFS schedule than it is to do real time, because it means they need, obviously hardware on the vehicles and things like that. But you shouldn't mix the two up. It's just to kind of, make sure that there's two separate lanes you're talking about there.
Gotcha. That's actually good to know, because yeah, real time, there will be a difference between the actual. So if the actual, because that will affect the way that things change, right? If I'm not mistaken, then Chris, a change to the GTFS structure would not actually be, it's not happening on like a daily frequency. Is that right? Like, what's the frequency of change on a GTFS?
Yeah, usually there's like, there might be, well, in the data, it can code sort of weekend trips and weekday trips, or you can specify different schedules to run on different days. But it's going to change, quarterly, maybe, if they're readjusting the routes or things like that.
Gotcha. Cool. And so in a situation where you wanted to sort of understand changes to routes, you would do GTFS. But if you wanted to do changes like actual like tracking of, we did an article recently, Chris, you can speak to this, about the actual like subway or the buses sort of being delayed, and that was a completely separate API. Am I correct on that?
Yes, and worth noting that's actually not GTFS real time. It's another API for tracking real time vehicles called Siri. So long background and story there, but GTFS real time is in use on the subway trains in New York City, but not on the buses, if I'm not mistaken. GTFS real time also uses protocol buffers. So you get one giant file with the entire system in it, and then you gotta parse it on your end.
Gotcha. Okay, cool. Then yes, Holger, hopefully this helps to sort of like, hopefully we can put together a demo for you here that gives concrete information of what query can do that is in the context of GTFS, because that was the closest thing we have to, and feel free to guide this as you like. But I'll share my screen really quickly just to show you two of the things that I think might be useful for some of what you're talking about. Based on the Twitter chat, it was like, we're trying to kind of get a semantic introspection into what changes in a feed from some transit API over time. So we have a couple of things we can offer for that as query. So query at the core is a version control system for data sets. The one thing to keep in mind is the way that we monitor, we measure data sets is a data set is a single table. And so we don't have a multiple table tricks, but instead what we do is we have every user on query gets a namespace. And so in the example of a GTFS feed, which is separated into say 11 files, the files all have a natural suffix like times, feed info, transfers, calendar dates. You can append that to the name of the data set, and now you have something that looks a lot like a collection of tables. It's just in a single namespace. So you could do, in our case, we were doing the MTA here in New York, we would do, my username is B5, I would do B5/MTA GTFS and underscore GTFS underscore times underscore transfers, and that would give me all of the sort of tabular structure. The reason for every single data set being only a single table sort of makes more sense once we get into the querying side of stuff, but the main goal was to have a very specific and granular definition of the specification. There are some tricks you can use to sort of link things together, mainly using metadata to make sure that in search, you sort of get the same results when you're searching for the same stuff. Every data set inside a query is versioned, and it's versioned in the classic sense that, yeah, if you're familiar with Git, every version is a snapshot and it's immutable. And so, a version history is created when you create a new snapshot that references the one prior, which query does for you automatically. Under the hood, query is using a decentralized file system called the interplanetary file system to move around data. And the reason for this is to make sure that we can sort of make an open data system that has no single point of failure. So ideally, you can move data sets directly between people that you're working with, or through a centralized service if you'd like high availability of that data. So we have a cloud service that backs up this decentralized network, and you can put stuff there, and then your colleagues can grab stuff from there, and that means that you can both be online at different times. But that shouldn't stop you in a situation where, say, the internet gets not so great, or our cloud service isn't 100% uptime. You're still able to move data around. This is a little different from Git in the sense that when you type query connect, which is the phrase for going online, peers will automatically find each other. And so query has a mechanism for reconciling where somebody else's location is and pushing and pulling to them automatically. So you don't have to sort of like be able to text message each other. I'm running a server, dial this IP address type stuff. Yeah. There's some other stuff, but I'll just quickly share what some of this might look like. We also do, I think the thing we might want to show you today is just how difference calculation works inside of query. So query has a built-in semantic data differ, which allows us to sort of show the difference between two data set documents. So I'll quickly just sort of demo some of that stuff. Ideally, and feel free to sort of stop me and ask any questions as we go. But I'll share my screen. And so hopefully you can see a query desktop application. This is our desktop version. We also make all of this on the command line. And so I'll demo some of this as well on the command line if you're interested. This is our command line version. It looks like this. We hit query, we type enter, we get commands, we get help text. Our help text is a lot better thanks to Rob's contributions recently. But I've just quickly, the first thing I want to show you is just the diffing tool, which might help if you don't want to use versioning at all. Just understanding, being able to use some of these tools for calculating differences is sometimes worth it. So in this case, I've gone ahead and downloaded the VBS GTFS dataset that was sort of being discussed online. And so this is, oh, these are TXT files. I have to change their extensions. These are actually CSVs. Okay, so let's do CSV. OS ECMOSS is going to yell at me. Let's do transfers to, and then transfers. So in this case, I'm just simulating some changes between two data sets. These are not real changes, but just so that you can see what a difference looks like in the structured data context. I now use what? Why am I not allowed to use this? Why not? What is wrong? Oh, there we go. I just had to wait, apparently. So if I do transfers CSV as the first thing I'd like to check as a difference, and then transfers to.csv, I can load this up. This will go through and calculate a change set for me and show me that in this case, all that's changed is I've removed lines from the bottom, basically. And so this is what a set of, what is this, sort of like 9 or 10 subtractions looks like in a difference calculation. So I can sort of spread this out, open this up. But it'll do sort of calculate column swaps, it'll calculate sort of single field changes, anything that you sort of need to see. We can collapse all these changes and just show that this is, if we flip these, it'll make more sense. But that's sort of the basic sort of diffing two CSV files classic. Getting the output of this is sort of the first thing that you can do even outside of any versioning that is kind of helpful for understanding just some of the conversation we're seeing on Twitter around understanding what some of these differences look like. You can get a version of this that is command line, purely command line. So if we do the query diff tool will actually do that for us. I'm now going to have to change to my downloads folders. This is going to be interesting. Downloads. And then was it VB, or what's the directory here? VBS GTFS. Query. So I again can just query diff transfers .csv and then transfers to CSV. So again, this is a trivial change, but I can give this, and this will calculate and give me, oh, I'm running query, hold on. This will give me a massive description of context, followed by at the very bottom, the same output, which is intended for just like console display on the command line, but we can also just do format JSON. And this will give it to you in a machine readable format. We can pipe this to JQ. And we have a specification that describes how this looks and works. But basically this is similar to what you would see in git diff, where the first thing in a cell indicates is this a removing of line 8602 from the left document, and then the description of the thing that was the value that is being removed. This happens in a structured context, and I can sort of link to how that works. But if you wanted to sort of just use the diff tool, you can sort of pipe around that if you have something that is versioning. Obviously, query comes with a version control system under the hood, so I can just do query list to show data sets that I have in the past. And some of this is sort of like a nice way to sort of just examine version data. So I can just do query log in the classic Git sense. This is just going to show this is a single version data set as it stands right now. This IPFS hash is the actual hash of the data, and that could be moved around independent of our tools. But sort of is ideally the like high level view of stuff, we have lots of commands for editing and creating histories. So like query save creates histories. And the other thing that we have is some mechanism built into query to sort of automate the updating of these data sets. And so that's a lot. I mean, I can sort of stop there and demo anything else that is useful, but that's kind of the bread and butter of, ideally is getting close to what you were, the questions that I was seeing on Twitter, and sort of answering some of those questions. Does anything come out of that?
Yes, and I guess handling additional columns works likewise. And is there some kind of transaction if I want to version a GTFS feed which consists of multiple files? Do I need to do transactions or commit all tables in one transaction, or how does?
Totally. The way we would generally structure that, if you're willing to sort of like play entirely in our sandbox, we would use something called a transform script for that. You don't need to do this. So you could, in many situations, if you were downloading 11 files and you wanted to sort of like have that all be transactionalized, you could basically use the query command line tools and wire around them with query save to say, okay, cool, we're going to write a script in your language of choice that downloads everything. And then the last step would be a series of 11 query saves at the same time. Sometimes that's, and for transaction checking, we'll pick some sort of identifier for like saying, cool, this is the version of that run of that script. That's if you want to get super, if you want to keep everything really custom in your own sort of universe. If you do it sort of on our side of things with the embedded syntax or the embedded language, we use something called a transform script for that. And for this, I think it's easier to sort of share the docs on our documentation on our website, which has gotten a little bit better over time around this topic. But if I go to query.io docs, the way I would sort of recommend structuring it, if you wanted to use Starlark transforms, are basically look a lot like Python. And so this is an example of one. This is a transform that sets the metadata of something. But they can get far more sophisticated where you can quickly start loading HTTP packages and doing downloads of stuff. Starlark also includes a zip package and a CSV package. And so what you could do is write 11 simple transform scripts that would be, and run them sort of individually and hook one of those up to each table. And now you have you have the downside that you're actually downloading from the central server 11 times. But the upside is when you write it this way, if nothing changes about that table, there is no new commit created. And so the way, instead of shaping a transaction as a new commit for 11 data sets, you would have 11 checks that are running on a sort of timer. And if there is nothing new, then no new version will be created. And so now you're only creating data for the tables that are changing. And so in the sort of classic GTFS, it looks like this. Stop times is the largest data set by a good margin, this 126 megabytes of CSV data. Maybe that one is changing with much less frequency, and so you can set it up to check at a different rate. But these transform scripts allow you to sort of say, cool, this actually, when you run it, binds with the data set itself and gets embedded into the data set so that when you move them around, other people can rerun these transform scripts themselves. And so it makes for a little easier of a transfer around of the burden of actually maintaining some of this stuff. The transform scripts themselves run in a sandbox, and so you can be reasonably confident that it's not going to do anything that you don't want it to do. So I think it's kind of a long-winded answer, but on one side, you could build an ETL pipeline that downloads the stuff. On the other, you could write 11 transform scripts, each that download that zip file, unpack it, pull one table out, and make that the data set.
Yeah, okay, so thank you very much, and I will surely have a look into and get some things done.
That's great, and thanks even for the questions. It's really helpful to know what use cases people are trying to chase. It's really, for us, this really helps. Like we really struggle with, should a data set be able to contain multiple tables? And we're kind of researching the idea of a data set that is a list of other data sets as a way of doing sort of a package that combines many others. But we're not, I can't say we're anywhere near starting that work yet. We're still getting our feet good with making sure everything that we currently make works consistently and well. Cool. There's something from chat, but oh yes, good. Thank you for the docs link, Rico. Yeah. Yeah, I guess I can leave the floor open. Did anybody else have anything from I know Rusty and Christos, you've been doing transform writing, and Rob, you've been filing bugs all over the place. Anything jump up that you sort of wanted to talk about with the using query side of things?
Oh, you're muted, Christos.
Oh, you're muted, Christos.
Nothing's really jumped out to me yet. I haven't really got my hands dirty with transforms. I just kind of dabbled with it with the demo that you showed last time. So this week I plan on trying to make some sort of ETL of the data that I'm working with now, so it can continuously update missing pages from Bandcamp, because I've been seeing a lot of those, and kind of just removing those as they pop up.
That's great. That makes a lot of sense. We found some issues with dry run inside of transforms, which we'd like to fix. But Rusty, sounds like you've got comments. Rusty is our head of QA these days. He's been doing a lot of good filing of quality problems.
Hey, everybody. I have a working transform as of this weekend that does, I don't know, most of the modules, bsoup, JSON, CSV. I think there's 5 imports. It's working great. I have some issues to file, and I probably for off call have something to talk about with Brandon or whoever else is in charge of StarLib. But it's working great. It's been difficult to test without print working, but that'll work in the future. And I also found the dry run works if you make a structure. That's not filed as an issue yet, but if you don't file it, Brendan, I'll file it and comment on the fact that it works if there's a structure. And so if you put a dummy structure and you do get an output from dry run. And that's all I have to report, really.
That's fantastic. Thank you.
I think print should be working now. I think we put in a fix that'll make it function correctly. So
With no new release, so just build it.
Yeah, if you're working from releases, then we should do a release at some point soon.
Okay, so it works in
yeah, we've got it in master, but we need a release
and a
for
build
sure.
of if I build it myself.
Right. Yeah, if you're not already like building from source, then like
excellent.
That's on us to do a release with it. Like, don't feel like you have to dedicate going into hard mode. It's fine.
I could also share some of the documentation updates.
No, I could build it.
Chris, it'd be great to hear your docs updates. Oh, Rusty.
Yeah, I think most notably rearranged some of the existing content, but I wanted to share specifically this page called docs/transforms/examples. And you can see, well, it's over here under the transform section, which used to be called Starlark, but now it's a little more straightforward. So under examples, we've got 3 sort of well curated example scripts with a little paragraph of text about each one and what it does. So it's just kind of an easier entry point into starting to understand what the scripting language can do. The first one is actually web scraping, so it's using bsoup to parse the HTML response from a website and then pull out a table from a HTML table. So I won't go through the details of the code, but I'm just going to cover the three we've got so far. World Bank population is in a JSON API response plus an existing query data set. So this is a good example of using a query data set, a smaller query data set as like a lookup table or a filtering table to make more sense out of an API response. And then the third one, which is the most complex, is counting NYC 311 complaints by borough, which basically downloads a Polygon GeoJSON file and a point data set, and then does a point in Polygon spatial join with counting. So this is basically pulling down live 311 complaints and then spitting out a table that has georeferencing them and putting them inside of a polygon, then counting them, and then putting out a table that has like a count by community district. So this is all doable inside of Starlark, because Starlark's got some simple geo functions in it. And we hope that this will be like a good place where people can do pull requests with other examples that will be helpful. And we can have a nice little index over here on the right side of interesting transform scripts that can help people get started. That's all I got.
That's fantastic. Yeah, and that's actually kind of useful for, particularly as we're talking about geospatial, like as we're dealing with some of these sort of crises at hand, the capacity to be able to sort of say, cool, something within this country boundary, something within this lat long is an easier, being able to sort of script that is something that we should probably be looking at a little more. I apologize for, we're also doing childcare at home. I don't know if you're hearing this, but yeah. Yeah, what was I gonna say? And then last but not least, we've kind of demoed this a little bit, but I thought I'd quickly show that the next feature that we're hoping to land with Query is the capacity to actually execute queries against data sets as SQL, which I think is something that has been a long time coming for us. The initial white paper published around Query was built around the idea of doing transactional SQL across a version control system. But just to sort of like give a really quick, I'll give like a 30-second demo. This is a command line side only thing for now. Just quickly share my desktop. But basically the command that we're going to be shipping I think either we will get our act together and ship a release for you, Rusty, and so then it'll be a patch release, or we'll wait for one more release to sort of clean this up and land it. But this is how it'll kind of look in the end, is when it lands in the command line first, and then we'll be sewing this into the user experience on the desktop side. But basically we have this new subcommand called SQL, which lets you run SQL against data sets themselves. And so the one thing we're sort of one place where we're deviating from the SQL spec itself is you're actually able to name data set references directly. And so this is B5 COVID-19 deaths. I'm doing this as a table D, and I'm doing limit 4, and I can run this and it'll quickly give me everything from that, which is a bit much. So let's just do country or region, because that's a little easier to read. SQL select D country region from B5 COVID-19 deaths D limit. Let's do limit 20. So cool. Order by country region again. Descending. Oh man. Oh, I have to do order by first, don't I? I need to learn my SQL. Apologies, everybody.
SQL is weird. It's okay.
I'm just like, I'm out of practice. It's been a while, but we can sort of like flip those orders around, which is great. But the thing that is exciting about this to us is these things that we're referencing are version control data sets on a global sort of system. And so I can actually reference and union and join stuff across numerous data sets. So ideally, Holger, where this sort of draws everything back is those 11 tables, while they are not sort of causally connected as a package, you can use them as if they're in the same database, which will ideally make for querying and assembling data, particularly when you are actually tracking identifiers in a way that is consistent across a set of tables. This will be a really powerful tool. Yeah, and so like the nice thing here is we can actually, we've sort of set things up so that this can actually be a reference to a specific commit. So if you wanted to say point to a specific point or version of a data set, you can actually compare how a selection or how a query would run against the latest commit or a specific point in time, subbing those things out. And query will do all of the resolution and querying in the background. So yeah, it's a very simple demo, but I think it sort of speaks more to the potential than anything else. I think it's just really fun to play with as well. And so we'll be sewing this all directly into our desktop project as well, so that you'll have something that looks a little like type a query terminal and then a sort of like table that'll give you everything on the other side. So that's what's coming. We were hoping to have that up kind of the next couple of weeks, or things are coming together pretty quickly on it. But ideally what this gives us is like a world where we can sort of be publishing open data and querying each other's data very quickly and aggressively. And so some of the work, Genevieve, that we've been doing, it would make for much faster insight gathering around, okay, cool. We now finally have the postings of sort of like what each NGO is doing in terms of their funding. And now we can start to, we were having conversations in prior sort of projects where we could, what would it mean to sort of cross this data with that data? Well, we can now actually do that inside of the system in a much faster way. And so ideally that means just assemble some like raw information and then start to ask questions, and we can generate insights a little quicker.
Cool. I think we hit most of the corners. Rob and Genevieve gave us already 35 minutes of their time, so I'd love to know if there's anything on their minds or to-do lists or their query world where we could be particularly helpful or supportive or whatever. Rob's like, we've been thanking Rob on every call for all of his contributions, and it's never feels like wasted time to do it again, which we could spend a minute or two doing that. But Rob, anything else on your mind or workbench?
I don't think I have any lingering questions right now. And no need for the profuse thanks.
Of course there is. This is open source. We're all here because we care, not because we need to be, and so we're eternally thankful for that. But yeah, it's great. I think we've got some fun stuff coming up. I think the next couple of weeks are mainly just going to be clean up and fix and clean up and fix and clean up and fix and ship SQL. That's the main goal for now. But cool. And Genevieve, is there any type of data that you'd like to see emerging, or like I know we talked briefly at the top of the hour about this scramble that's happening in the NGO space? Is there anything specific that like anecdotal trends that you're noticing that we might be able to sort of back up with data?
Yeah, I think I don't have anything specific. This has been great to both be able to sort of eavesdrop and also just to see other people since I work alone. So this is really nice. But yeah, like one thing that I'm thinking about, and I don't know how to do this yet, but I would love to circle back with you guys once I have something concrete that maybe you can help me with. But a lot of foundations are lifting the restrictions on their funding right now. And so saying you can use this grant that was specific for program for general operating costs, like keep your people paid, and we can, if you know, something was a loan, we could talk about extending deadlines, extending reporting deadlines, things like that. So something that I'm sort of scheming on is how do we monitor that in a light touch way to make an argument that after all of this is, after we're out the other side of this, not for foundations not to reimpose those restrictions, to say, hey, this is actually the better way to give, and this is how philanthropy should work anyway. And so I'm wondering if we can say, this is what trust-based philanthropy looks like, keep doing it. Don't go back to whatever the new normal was around that. So I'm looking at that with foundations and sustainable finance, sort of. Our colleague Tom and I are working on a paper on that right now. So as usual, doing a lot of like blue sky conceptual sort of like, how do we tear it down thinking, but doing a lot of research into that. And so if I can come up with some, what I think is relevant, at least metadata around that, I'll circle back to you guys and you can tell me if I'm full of hot air or not.
That's really interesting. That's really, really interesting. That, and like based on the work we were doing prior, so just to like give others some background, Genevieve and Query were doing a sort of collaborative, trying to mine in the United States. There's a form called Form 990, which all charities must, charitable organizations must file. And Amazon actually makes all 990 filings available in the machine readable format for free through S3. So you can just download the 990 filings of a lot of projects. What you're describing, Genevieve, would go below the granularity of what we currently have in a big way. I think the best way to sort of capture what you're describing would be understanding when projects exceed their deadline would be a simple heuristic. Because I mean, it's not like everyone has to file in metadata, change in parameters or requirements for funding. And so it'd be interesting to understand what happens to project timelines around this time, and the thing that put back to you is what is the success metric, and that's a very difficult thing to sort of get your head around. Which you're far more tuned into this than any of us. So.
I do a lot of hand waving about it, but I do think if we see a trend of a spike in disbursements means that folks are, you know, moving away from a grant cycle or moving away from, yes, we'll disperse the money every quarter, whatever that is.
That's a
So
really good point.
yeah.
Yeah, and based on what we were doing last time, there was disbursements are captured the same way that grants are they not? Yeah, shoot.
Yeah, and it's kind of like everything else, you know, the financial stuff tends to be a really good proxy. But yeah, so between that and all of the, you know, mutual aid work going on, that a lot of folks are using different collaborative software to organize around that, those are the things that I'm paying attention to right now. So yeah.
Fantastic. Okay, that's a lot. That's a lot to think about on the data side. Yeah, I think that kind of covers everything we wanted to cover today, and I'd rather either A, leave this as free and unstructured time for us to hang out with our cats and friends, or B, just leave any room for any extra questions.
She does not understand Zoom etiquette at all.
None of them do.
Yeah, anything else we can help with?
I would just say, Holger, thank you so much for tuning into the call. This is by no means the last time we'd be willing to talk to you if we need help or you've got questions or ideas about how you want our software to work for projects like yours. We're still very much in the early stages, so we're designing around use cases that mean that'll actually add value to real people. And so if you want to be one of those real people, then email us, tweet at us, come to these meetings, whatever we can do to help, we're here.
Thank you very much. So thanks for the work already, and I will join in future often if I can. So
cool.
Thanks.
Thank you so much. And thanks everybody. It's so nice to see all of you. Awesome. Have a good one.
See y'all.
Bye.